Hey all, today we're going to continue our discussion about congruent triangles, and we're going to talk about some really important theorems. So we're going to talk about 3 of them today, talk about 2 of them in the next lesson, and these are all ways to show that triangles are congruent without knowing all of the sides that are congruent and all of the angles. So we've got a few things to add to your flipbook, so pause here, add this stuff to your flipbook, and then listen to what I have to say. So we said with 2 triangles that all the corresponding angles and all the corresponding sides are congruent. We know that the triangles are congruent. So what if we don't know the triangles are congruent, but we know some stuff about them? So the side-side-side theorem, which we refer to sometimes as SSS, and that'll be okay, says that if you know that 2 triangles have all their corresponding pairs of sides congruent, then you can say that those 2 triangles are congruent even if you don't know anything about their angles. So all you need to know is that 3 pairs of sides are congruent. So here we have side AC and side NL are congruent, side AN and side LM, and side CB and side NM. So even though we don't know anything about the angles, we can say that these 2 triangles are congruent by the side-side-side theorem. Add this to your flipbook. So pause here, add this to your flipbook, and then listen to what I have to say. So the next theorem is called the side-angle-side theorem, which we often refer to as SAS. So if we have 2 triangles and we know that 2 pairs of sides are congruent, so here we have AC and NL, we have AB and ML. That's 2 pairs of sides congruent. And we also know that the included angles are congruent. Now that's a really important vocabulary word. The included angles are congruent. So an included angle is an angle formed by 2 sides of a triangle. So the included angles in each of these triangles are formed by the sides that we're using to say are congruent. So this side I marked in yellow and this side in green, when they come together, they make angle A. This side in yellow and this side in green, when they come together, they make angle L. A and L are the included angles. So if I have 2 pairs of sides congruent, I got my yellow ones and my green ones, and the included angles, so the angles formed by those 2 sides in each triangle, if they're also congruent, then we know that these 2 triangles are congruent to each other by the side-angle-side theorem. And then to take it back to the lesson before this, once we know that these 2 triangles are congruent, then we can use our CP/CTC to say things like angle B is congruent to angle M, and BC is congruent to MN, and so on and so forth. We'll get more into that later. Right now it's important to be able to see the side-angle-side theorem. One more theorem today to add to your flipbook, and then we'll do a little practice. So pause here, get everything down, and then listen to what I have to say. So if we have 2 right triangles, we have a special theorem for them to show that they're congruent. So the first thing we need to know is that they're right triangles, so they have right angles like these 2 do. And then if we know that their hypotenuses are congruent. And just a reminder, the hypotenuses are across from the 90-degree angle. So I've actually written that here. And it's also the longest side of the right triangle. So the hypotenuse is across from the 90-degree angle, the longest side. If those 2 things are congruent, which they are in this picture, and also 1 pair of legs, so 1 pair of the other sides, so like AB and ML. So I have a right triangle, the hypotenuses are congruent, and then 1 other pair of sides, which we call legs, are congruent. Then we have the hypotenuse leg theorem, or HL. And we can say that those 2 right triangles are congruent to each other. So now the important thing is being able to identify those things. And I want to point out a couple of things we talked about a couple lessons ago that exist in these pictures. Whenever we have 2 triangles and they share a side, like in this first one, and this third one, we know that those sides in each triangle are congruent. And remember, we call that the reflexive property. So in the first and third pair of triangles here, I have the reflexive property identified. And also, whenever we have a situation like this, where I have two lines intersecting, remember we have vertical angles. So those two angles are congruent. So if we have two sides in the same triangle, or we have vertical angles, we can always go ahead and mark up these pictures, saying that that side is congruent in both triangles, that side is congruent in both triangles, and these angles are congruent. So even though it wasn't already marked on the picture, we can mark it ourselves. And I'll write there, it's vertical angles. So now we want to identify which we have. Do we have side, 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 angle, side, or HL? So in this first picture, I have a right angle, and so that means that's a right angle. So it looks like we have right triangles. These sides across from the right angles are congruent, so the hypotenuses are congruent. And then this reflexive property shows us that one of the legs in each of the triangles are congruent to each other, so we have the hypotenuse leg theorem. Here I have two pairs of sides congruent. I have one right there. I have another right there. And then I have the included angle. I have the angle in between the blue and yellow sides in each triangle are congruent to each other. So this is an example of the side angle side theorem. And lastly, in this triangle, I have one pair of sides. I have a second pair of sides. And then that reflexive property allowed me to say that this third pair of sides in each of the triangles are congruent. And so therefore, I have three pairs of congruent sides, which tells us the side, side, side theorem applies. So in the first one, I can say that these two triangles are congruent by hypotenuse leg. These two triangles are congruent by side, angle, side theorem. And the last two triangles are congruent by the side, side, side theorem. So I want you to pause here. I want you to try and identify which theorem applies to each of these triangles. It's not super important to draw the triangles as long as you drew the other three, but just identify which theorem applies. So in each of these triangles, the reflexive property applies because I have a shared side in each of them. So in each of these triangles, I can identify a pair of sides that are congruent using the reflexive property. And that's going to be important. In the first one, we have right angles. The side that's shared is across from both right angles. So that's the hypotenuse in both triangles. So I have the hypotenuse is congruent. And then I have another pair of legs congruent. And so therefore, I have the hypotenuse leg theorem. In this triangle, I started out with two pairs of congruent sides. We were able to name a third pair of congruent sides because of the reflexive property. So that gives us side, side, side theorem. And last, in this one, I started out with a pair of congruent sides. I identified another pair of congruent sides using reflexive property. And then the last thing is that these angles here that are congruent are between the green and blue sides. So those are included angles, and therefore I have side, angle, side. It's very important to be able to identify these included angles because sometimes we're going to get triangles that have angles congruent, but they're not the included angle, and therefore side, angle, side doesn't apply. So one more way we're going to see these theorems show up is if you have some information given to you, and then you want to identify what other piece of information you would need to prove the triangles are congruent using a specific theorem. So in this problem, I have two right angles. I want to identify the hypotenuse of these triangles. They're across from the right angles, so FE and ZY are my hypotenuses. And it looks like I'm shown using these tick marks that FG and GY are congruent. So I have a pair of right angles and I have a pair of legs that are congruent. So in order to use hypotenuse leg, I need to say something about the hypotenuses being congruent in order to use that theorem. So in order to prove these two triangles congruent, I would need to tell you that side, whoop, I wrote it wrong. I would actually need to tell you that side FE is congruent to side ZY, the two hypotenuses. In this triangle, we want to mark up the things we know, even though they're not shown. So we know that these two sides are congruent, even without anybody telling us that because of the reflexive property. So in order to use side, 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 the pair of sides we need to be told are congruent are these two sides right here. We already know ST and GT are congruent. We know RT is the same in both triangles because of reflexive property. So in order to use side, 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 we need to know that these two blue sides are congruent to each other. And last but not least, in this triangle, I know those two sides are congruent. I also know that TU is the same in both triangles by the reflexive property, so I know that they're congruent. In order to use side angle side, I need to identify the included angle. So it's the angle between the green side and the yellow side in each triangle. So the green side and the yellow side in this triangle on the left form this angle right here. The green side and the yellow side in this triangle on the right form that angle. And so my two included angles that I would need to know are congruent are ETU, ETU, and VUT. So go ahead and pause here. I've given you two to try. For the first one, I want you to do side angle side. For the second one, use side, side, side. And I want you to identify first the information that's not marked on the picture that you know because of some geometry knowledge. And then tell me which other piece of information that I would have to tell you in order to use the theorem to prove the triangle is congruent. So in the first one, the thing that we already know are that those two angles are congruent because they're vertical. In order to use side angle side, we would need to identify one more pair of sides congruent. So we know that those two are congruent. These two congruent angles are between these green sides and also these two sides. So in order for them to be the included angle, we need to know that GL is congruent to LK or KL. That mean the same thing. In this triangle, I know that these two sides are congruent by the reflexive property. I'm also shown that those two sides are congruent. So in order to use side, 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 the two sides I would need to tell you are congruent are KL and LQ. That's the missing piece of information. And so that's what I would need to know. So I've got two for you to do. Please make sure that you copy these pictures onto a separate sheet of paper that you can hand in to me. Put your name on top. Show me your work. So you should be marking the picture up with things that you know. And the first one, I want you to tell me which theorem proves the two triangles congruent. And the second one, I want you to tell me which piece of missing information you would need to know to prove the triangles are congruent. And specifically in this second one, I want to know they're congruent by side angle side.